Hi students, welcome to Konnur's online video classes. Now, in a previous class we are discussing about number system, basic concepts and some problems. Now today we are discussing about some important concepts. The first one is rational number. Here, rational number. We have already discussed, but some points are there. First, you have to understand what is a rational number. Rational numbers are in the form of p by q. Q is not equal to 0. P and q are belongs to the integers. Here, in symbolically, q is denoted by rational numbers. Q is equal to p by q, comma. Q is not equal to 0 for all, this is the for all symbol, for all P and Q are belongs to the integer. This is a definition of rational number. Now once again I will explain this point. The rational numbers are denoted by Q. The rational numbers are in the form of P by Q. Q is not equal to 0 and this symbol is a for all. Here this symbol is for all, and P and Q are belongs to the integer. Belongs to means what? P and Q are in integers. That's why this symbol is belongs to. Belongs to. Now, and the rational numbers based on some decimal expansions are formed. Two kinds of decimal expansions. The first one is terminating decimal expansion, and another one non-terminating, recurring decimal expansion. Decimal expansion. First you have to understand terminating decimal expansion. Terminating decimal expansion means by using the long division method, we are taking rational number. The given rational numbers are completely 0 after dividing. Here, for example, 1 by 2 is a rational number. Now, by using the long division method, here this value is 0.5. Now, this is a decimal expansion too, and the given rational number is completely divisible. That's why this is a terminating decimal expansion. Now, one more example you take. The one more example is 2 by 5. And this value is equal to, you take a point and 0, 20 is formed to 4, 5 ones are 5 fours are. Now 2 by 5 value is 0.4 is a decimal expansion of the given 2 by 5 term. Now these two rational numbers we observed, these two are completely divisible. It means the remainder is 0. That's why these two are the terminating decimal expansions. After long division method we are using, now remainder becomes 0. That terms are called a terminating decimal expansion. And the next one is non-terminating decimal expansion. Non-terminating recurring decimal expansion. Non-terminating means opposite word. Terminating opposite word is non-terminating. It means the remainder never 0. After using long division method, the given rational numbers is not completely divisible by 0 is called non-terminating recurring decimal expansion. For example, 1 by 11. Now after simplification, here you take a point at 0. 10 is formed, but 10 is not divisible by 11. That's why you take a one more 0, and here this value is 100 is formed. 11 ones are 11 nines are. Again 1 is remaining. You take a you are already considered a point. Take a 1 0. The value is 10, but 10 is not divisible by 11. That's why you take a one more 0. The value is 100. And again 11 nines are. It means 1 by 11. 1 by 11. The value is 0.0909 and so on is formed. That's why 0.09, 0.09 and so on. 09 is continuously repeating or recurring. That's why you take in the form of this. It means 0.09 bar. Bar means the bar is related to the 0 and 9. The 0 and 9 is continuously repeating. That's why you write it in the form of this term. Now, first you understand terminating, and next one is non-terminating. And one important point is, this is very important concept, all rational numbers are terminating and non-terminating recurring decimal expansions. Now this statement is very important, you concentrate it carefully. Now the rational numbers, all the rational numbers are terminating and non-terminating recurring decimal expansions. And one more is irrational number. Irrational numbers means the given numbers are not in the form of p by q. I have already explained this point in irrational number definition. Once again I will explain here. The irrational numbers are denoted by here irrational number irrational numbers are denoted by IR or Q dash. Now irrational numbers are denoted by IR or Q dash, but this definition is that irrational numbers are not in the form of P by Q is called an irrational number. And one more statement is the irrational numbers are in the form of a radical is also another definition. Both are correct. Now you have to choose it. First one is the irrational numbers are not in the form of a p by q, and one more definition is the irrational numbers are in the form of a radicals. Now, and the irrational numbers related one more decimal expansion is also formed. For example, irrational numbers first I have here. The examples are 5, e and root 2, root 3, etc. etc. Here the irrational numbers are pi, e means exponent value, and root of 2, root of 3 and so on, etc. It means infinite number of irrational numbers are there. Now all the irrational numbers are non-terminating and non-recurring. It means after simplification the decimal numbers are not repeating or not recurring. For example, pi value, the pi value is 3.141 and so on is formed. These decimal numbers are not repeating continuously. And you have to understand that first there is terminating decimal expansion. The given rational numbers are division, but the given rational numbers are completely divisible by 0. The remainder becomes 0 is called terminating decimal expansion. And one more is non-terminating decimal expansion. It means the given rational numbers after using a long division method, the remainder becomes not a 0. That's called non-terminating recurring decimal expansion. And the next one is irrational numbers. All the irrational numbers are non-terminating and non-recurring. Non-recurring means non-repeating. That's why the irrational numbers definitions are pi, e, root 2, root 3, root 6, root 10. These are all, but not perfect square numbers. Root 4, root 9, root 16. These are irrational numbers. Now, this concept we have studied. The next one is these concepts based on some exercises problems are there. Now, the next exercise 1.3. Here, the first problem is write the following in a decimal form and say what kind of decimal expansion each has. It means we are already discussed terminating, non-terminating, recurring, non-terminating, non-recurring. These are the decimal expansion types. Now you have to identify it. The given questions are there. Given questions are in the form of a rational. Here, the first one is 36 divided by 100. Now this is a form of a P by Q. You have to convert in a decimal expansion. How? See here, the denominator is 2 zeros are there. That's why you already studied in a 7th standard rational form to decimal form. Now this decimal form is 0.36. Now 0.36 is a decimal expansion. That's why here this problem we observe 36 is completely divisible. It means this is a terminating. The given problem 36 by 100 is a terminating decimal expansion. Terminating decimal expansion. And second question. The second question is 1 by 11. Here 1 divided by 11 you take. Now first we are using long division method. This is a very simple procedure. You are already studying as 5th standard. Here you have to divide it. 1 is divisible by 11. Now we observe 1 and 11. 1 is smaller than the 11. Take a point and 0. Here 10 is formed. Again we observing this number. 10 is also not divisible. 10 is smaller than 11. Again you take a 1 more 0 and here you take 1 more 0. Now the given value is 100 is formed. Now 11 nines are 99. Here you take 11 nines are 99. Then you simplify it. This subtraction value is equal to 1. Again we are already consider a point. This based on you have to take a 1 0. But again 10 is not greater than 11. That's why again you take a 0 and here is also you take 0. This procedure is a long division procedure. You have to follow it. Now again 9s are 99. Now this value is also 1. It means in this problem we observe. Now this procedure is continuously going on. That's why the value is 0.9, 0.09, 09 and 09 and so on. These values are formed. Now 1 divided by 11 is equal to 0.0909 and so on. Now in this system we write 0.09 bar. Now just you identify this is which type of a decimal expansion. Here terminating, non-terminating or non-terminating, non-recurring. Here the second one is a non-terminating. It means the remainder becomes not a 0 and 0909. These two numbers are continuously repeated. These two digits are continuously repeated. No, that's why this is non-terminating, non-terminating, recurring decimal expansion. Decimal expansion. And the next question, third one. The third one is in the form of an integer. 4 integer 1 by 8. Here, first you have to convert it. 4 integer 1 by 8, first you convert in the form of and p by q. Here, you have to multiply 8 into 4, 32. 32 plus 1, 33. Here 33 by 8. Now we are converted p by q for. Next, after we are using long division procedure. Here 33 divided by 8. Now again you take 4s, 32. Remainder is 1. 1 is smaller than 8. That's why you take a point and 0. 10 is fault. Again 1s, 8. After simplification, this remainder is 2. Again you take a one more 0. We already consider a point. That's why you take a 0. Then 20. It means take a 2s. 2s, 16. Now this remainder is 4. Then this value is 0. And again one more 0 you take. Now 8 5s are 14. Now remainder becomes 0. Here therefore 4 integer 1 by 8, the value is equal to 33 by 8. After simplification by using a long division method, this value is 4.125. It means the remainder becomes 0 now. That's why this number is terminating decimal expansion. Terminating decimal expansion. So here the remaining 3 questions are there, 4th one, 5th one and 6th one. Similarly you have to try it. Now once again I will explain all the points: terminating, non-terminating and non-terminating and non-recurring. Now the standard statement: all the rational numbers are terminating and non-terminating recurring decimal expansions, and all the irrational numbers are non-terminating and non-recurring decimal expansions. These two statements are very important. You have to concentrate it. Now remaining 3 questions are there. You have to try it in home. Now the next second question. The second question is very simple question. 1 by 7 value is given. Just you have to find 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7. Now this is a very simple question. Directly you have to multiply it to this number. How? See here. The given question is, you know that 1 by 7 is equal to 0.142857 bar. Can you predict what the decimal expansions 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 are without actually doing the long division? Now long division is not necessary because 1 by 7 value is given. Directly you have to multiply it. First you have to split the given values, then afterwards directly you have to multiply it. You get the result of the given problems. Here the second question is 1 by 7. Here 1 by 7 is equal to 0.142857 bar. Here 1 divided by 7, this value is, after by using a long division procedure, this is the result. Now 142857, these numbers are continuously repeated. That's why we write 142857 bar. Now the next question, the given problems are dependent on this value. Here first one is 2 by 7. 2 by 7 is equal to, you have to split it, 2 into 1 by 7. Now 2 into 0.14287 bar. Now just you multiply it. Here 2 7s are 14, take a carry 1, and again 2 5s are 10, again plus 1, 11 is 4, again you take one more carry. Then 2 8s are 16, 16 plus 1, 17, again you take a carry. Then 2 2s are 4, 4 plus 1 is equal to 5, and 2 into 4, 8, and again 2 into 1, 2. Now this decimal point is as it is, you write it, again you take a bar. Why? Because the next numbers are also same digits are formed, that's why directly you write it 285714 bar. And similarly 3 by 7 is equal to 3 into 1 by 7 is equal to, and 4 by 7 this is equal to 4 into 1 by 7, and again 5 by 7 is equal to 5 into 1 by 7 is equal to 6 by 7, and this is equal to 6 into 1 by 7. Now here you write 3 into 0.142857 bar, and here 4 into 0.142857 bar, 5 into 0.142857 bar, 1 by 7 value here you put it, then 6 into 0.142857, then these values you have to multiply it, you get the result. This is also homework. Now this is a very simple problem. Directly you have to multiply 142857, multiply it to 3, you get the result. Again 142857, you multiply it to the 4, you get the result. Simple multiplication. Then afterwards you take a bar, you get the result. Now this is very clear. And the third one is express the following in the form of P by Q, where P and Q are the integers and Q is not equal to 0. The first one is 0.6 bar, and second one is 0.47 bar, and third result is 0.001 bar. Now these problems are very important in examination point of view in 2 marks question. The given decimal expansions you convert it to the rational number in the form of P by Q. These problems are very important, you have to concentrate it. Now we are discussing first one. These questions are very simple, but you concentrate it carefully. Here, now the first question is 0.6 bar. 0.6 bar. Now 0.6 bar means 0.6666 and so on. It means 6 is continuously repeated. Now, and one more point is, the 6 is continuously repeated, you have to consider it. X is equal to 0.6666 and so on. Now in this problem we observed how many numbers are repeated continuously. Only one number is repeated. That's why one digit is repeated. One digit is repeated. This is very simple. You have to observe the given problem. 0.6 bar. Here bar is related to 6 only. It means the 6 is repeated continuously and up to infinity. Now you have to consider it. This value is x. X is equal to 0.666 and so on. This is I have considered equation number 1. Now, generally we observing equation number 1. How many digits are repeated? Only one digit is repeated. That's why you write one digit is repeated. That's why here you multiply it. Multiply on both sides by 10. Why you take 10? Only one number is repeated, you have to multiply 10. Two numbers are repeated in the given problem, you have to multiply 100. Three numbers are repeated. In the given problem, you have to multiply 1000. Now and so on. This procedure is continuously going on. Now, in this problem, only one number is repeated. That's why you have to multiply it 10. Now, 10x is equal to 6.666 and so on. This is equation number 2. Now, we observing equation number 1 and 2. Here, in LHS side, we observe 10x and x both are like terms. That's why directly you have to subtract it. Now subtracting 1 into, we get now 10x minus x is equal to 6.666 and so on, minus of 0.666 and so on. Here, and this simplification is 9x is formed, 10x minus of x, 9x, and this is equal to. After simplification, this is very simple subtraction. Now, all the decimal numbers you have to subtract it. The remainder is only 6. That's why x is equal to 6 by 9. Now you have to simplify. 3 2s are 3 3s are. Now x is equal to 2 by 3. Now x is equal to 2 by 3. Now after simplification, this rational number we get 0.666. You check it here. 2 by 3 is equal to 2 is smaller than the denominator. That's why you take a point and 0 20s for 3 1s are 3 6s are 18. Again remainder is 2. Again you take a point and 0 20s for this value is 666 and so on in this form. That's why this is a verification. Now x is equal to 2 by 3. 2 by 3 is a form of an p by q. No? That's why this value is therefore 0.6 bar is equal to 2 by 3 is an answer of the given problem. Next, second one, 0.47 bar. Here, the second question is 0.47 bar. Now you concentrate it carefully. In this problem, 0.47 bar is related to the only one digit, 7. It means the 7 is repeated continuously. That's why you write it here. This means 0.4777 and so on. Now in this problem, how many digits are repeated? Only one digit is repeated, 7. Because according to the given problem, 7 bar is related to the only one digit. That's why 7 is repeated continuously. That's why here first you consider x is equal to 0.4777 and so on. This is equation number 1. And again, how many digits are repeated? Only one digit is repeated. Only one digit is repeated. One digit is repeated. Then you multiply on both sides by 10. Then similar procedure you have to follow it. How? See here, multiplied 10x is equal to here 4.7777 and so on. This is equation number 2. Again subtracting 1 into, we get now 10x minus x is equal to here 4.777 and so on, and here minus 0.4777, or you take only 3 digits because here is only we have considered 3 digits. No, that's why. Now here you take 9x is equal to, just to simplify, you don't confuse it with subtraction of decimal numbers. You don't confuse here one side you write it 4.777 and so on, and the second subtraction value is 0.477 and so on. Here this is equal, all the decimal expansions are 0 and here it is also 0, but 7 minus of 4 is equal to 3 and take a point, 4 is as it is. It means 4.3 is a subtraction value. Here 4.3 is remaining. Now you don't confuse the subtraction of decimal numbers procedure. Now afterwards 9x is equal to, here 4.3 you have to convert it in the form of an rational. Only one digit, no, that's why 43 by 10 is formed. Then directly you cross multiply it, x is equal to 43 divided by 90. Now cross multiply, 9 into 10, 90 is formed. Now this is the x value. Now we already considered x is equal to the given problem, no? That's why here therefore 0.47 bar is equal to 43 divided by 90. This is the result of the given problem. Now similarly third one you have to solve it in home now, but I will explain all the points. 0.001 bar, it means in this problem how many digits are repeated? Now the third question, 0.001 bar, it means 0.001001 and so on. It means 3 digits are repeated. Now I have already explained the given problem, only one number is repeated, you have to multiply 10. 2 digits are repeated, you have to multiply 100. 3 digits are repeated, you have to multiply 1000. That's why in this problem, how many digits are repeated? 3 digits are repeated. That's why now x is equal to, you take a 0.01001 and so on. This is equation number 1. In this problem, how many digits are repeated? 3 digits are repeated. That's why you have to multiply 1000. Now multiplying on both sides by 1000, and next procedures, subtraction in 1 into, you have to follow the same procedure. You have to try it. Next class we will be discussing about terminating and non-terminating based on some problems are there. We will be discussing in next class. Thank you.